Hi everyone, I'm Amanda from BloombergNEF or BNEF, and I'm excited to talk to you all today about my thoughts on blockchain in the power sector. But before I jump into blockchain, I'd like to briefly share with you about what BNEF does. So BloombergNEF or BNEF is a strategic research provider covering global commodity markets and really disruptive technologies that are driving the low carbon energy transition. Our coverage assesses pathways for different kinds of sectors, from power to transport to industry to buildings and agriculture, and how they can adapt to the energy transition. So we help commodity trading, corporate strategy, finance, and policy professionals really navigate this change and understand how they would need to position themselves. So my team is called Digital Industry, and you can see us right in the top right of this figure. So basically, we look at how digital innovation is affecting these different sector transitions. So here's my agenda for today. At first, I'm going to talk a bit about big trends we see in the power sector, and then give like an update about what industry is doing today and the kind of current state of the blockchain power ecosystem. And then share some near-term use cases we think can be interesting for blockchain in the power sector. And then talk about kind of long-term trends and long-term possibilities that might follow these near-term use cases. So 3 big power trends in the power sector really are decarbonization, decentralization, and digitalization. So I'm going to try to break these down a bit. It's really clear that the power sector is decarbonizing, and quite rapidly so. We expect the average renewable share in the total power generation in the world to increase to just above 80% by 2050. So this means a huge opportunity in huge economies like Germany and the US and China. For example, we expect renewables to make for about 70% of total power generation in China by 2050, 70% in India, and 65% in the US. So as the power system decarbonizes, this also leads to more decentralized energy assets coming online. And there is really a clear shift to distributed energy resources and power generation on the distribution grid, especially in countries with things like good solar resources, cheap PV equipment, and high retail tariffs, or all 3. We expect to see a huge increase in behind-the-meter solar and batteries. So this means like in places like Germany or Italy, Turkey, Brazil, and Australia. So this is all good because it enables decarbonization, but it's also making balancing the grid a lot more difficult, because when millions and millions of decentralized assets come online, this is a very different way of working for utilities than the centralized one-way power grid that they're used to. So this might be where digital comes in. We believe that digitalization will be very important to manage complex grids, especially to integrate distributed energy resources and decentralized assets on the distribution grid itself. Digital technologies are needed for improved visibility of assets on the grid. And with this improved visibility and ability to control assets, we can then go on to improve efficiency, safety, and reliability of grid operations. So we expect, because of these benefits and really the necessity of digital in the power sector, for digital spending in global grid investments to go from about 20% today to surpass 40% by 2050. And this spending will mostly go to things like digital lines and digital substations, but also to things like software, like advanced distribution management systems or ADMS, and distributed energy resource management or DERMS, because these systems will be important to manage distribution grids and coordinate distributed energy resources in real time. Because as I said, as these assets increase, it will be really important for real-time or near real-time visibility and coordination and grid balancing. So this decentralization and digitalization of the power grid might mean that we need to shift to more distributed digital systems like blockchain. because systems like ADMS and NERVs are still pretty centralized. So it's interesting to think about what kind of new computing systems and databases do we need to support distributed energy resources. So what's new with blockchain in the power sector? As you all know, the technology received a huge amount of attention in the 2010s from VCs and startups and companies. And in the power sector, it received a huge amount of attention for its ability to decentralize trading, especially in peer-to-peer trading pilots, which really saw an explosion. Well, this is definitely interesting, considering that the power grid is decentralizing and could benefit from decentralized trading. So far, these kinds of pilots have faced too many challenges to scale up from pilots because of several reasons. So for example, challenges include a lack of regulation and standards for peer-to-peer trading. Is this even legally feasible? And challenges also include business model innovation and really uncertain business models. So how do we even make money from these kind of things? Challenges include digital readiness of the power grid itself. So is the grid able to support this kind of infrastructure? And also uncertain demand. The users want this. Utilities might not be able to benefit from this at this point. And do consumers or prosumers even care about peer-to-peer trading or who they sell their power to? And so these are all interesting challenges that exist right now for transactive energy and peer-to-peer trading. So as a result, we think that there can be other near-term opportunities that companies can look at first. And here is where we think 4 areas might be for blockchain in the power sector. So green energy certificates, power purchase agreements or PPAs, cybersecurity control, and data procurements. So now I'm going to go through each of these use cases with some examples of organizations exploring them. So with organizations, I mean startups, companies, and research institutes alike. And I just want to emphasize here as well that most of the projects I share now are also in kind of pilot projects or trial phases. So blockchain can help to support traceability through audit trails and enable small-scale players through tokenization and disintermediation. This can be really viable for green energy certificates, like renewable energy certificates or RECs. So here are 3 examples of companies looking at how blockchain's traceability and disintermediation can be used to make RECs more efficient and more accessible. So in Asia, the Energy Web Origin has partnered with the huge Thai utility PTT to develop a blockchain platform that the utility can use to track and trade RECs in the ASEAN region. And this is really in response to growing corporate demands in the region for green power. So PTT is trying to find a way that they can support this demand in a credible, traceable, efficient way. And RICO is a Japanese company who is a member of RE100 and also has a 2050 net zero goal. So this means that the company is very focused on decarbonization and sustainability. So it's developing its own energy management software in which it's also trialing a consortium blockchain for REC efficiency and audit trails. Basically, it's seeing this as a way to make sure that it can reach its 2050 goals as well. So I thought that was an interesting example of, in Asia as well, of a company developing its own consortium blockchain software for RECs. And finally, Photon. So this is really interesting because Photon is a startup and the official IREX or International REX issuer in Turkey. So using the Energy Web Origin toolkit, Photon is using blockchain in similar ways as the others really to track and trade IREX. So what I find interesting is a quote I found from one of the co-founders of Photon saying that they believe blockchain could double the IREX traded in Turkey. So basically, I think this means that for blockchain, if it is implemented for REX trading, it might even grow the market because it can enable small players both to sell and to buy REX. So speaking of enabling smaller players, I think that blockchain can also be very interesting for power purchase agreements or PPAs, which we have already seen quite a bit of activity in. Because blockchain can be used to enhance the efficiency of trades and enable smaller scale players to both buy and to sell PPAs. Because now PPAs are quite cumbersome to acquire, both in terms of money and in terms of time. So they're mostly available for large corporate buyers and sellers. So for example, WePower delivered a virtual market platform for retail PPAs to Australian retailer Mojo. And basically the blockchain uses tokenization to enable players, no matter their scale, to buy and sell retail PPAs. And Power Ledger is interesting because it actually bought a solar system in Australia to test its new settlement tool for PPAs, or for autonomous PPA settlements. They call it PPA Vision. So here basically blockchain is being used for creating an audit trail and to really ensuring that the data that they have is accurate in order to eliminate revenue errors. So I think this can also improve the efficiency of like back office processes and settlements, which can take a lot of time and money as well. So this is all really related to transaction and settlement fees, and also avoiding errors and managing risk. And finally, FlexiDAO did a partnership with the utility Iberdrola in Spain to test a blockchain platform to track both PPAs, but also energy origins and emissions. And the purpose of blockchain here was to create an audit trail again and to support compliance efficiency. So there's really kind of an overarching theme here of creating an audit trail, enhancing efficiency, and enabling smaller players, which is why we think that blockchain can really support PPAs no matter the scale, and to enable savings on administrative costs. Okay, here we go. So cybersecurity is one area I personally find very interesting and very important, because we saw as well that during the pandemic, utilities were more susceptible and vulnerable to cyber attacks because everyone's working from home. So we have some information that cyber attacks actually grew against utilities in the US. So I think blockchain in this sense can be useful for data integrity, immutability, and avoiding single points of failure in the power system. Because the distributed security that blockchain can support will be especially important in decentralized systems with more connected devices. And this is because hackers usually tend to target edge or IoT devices instead of the core centralized systems, which is maybe right now where a lot of the cyber efforts are, cybersecurity efforts are. So one example I like is the US Department of Energy project Blossom, which is led by NEDL, or the National Energy Tech Laboratory. And if anyone from NEDL is here, I'd love to talk as well. And I think this is a really, really interesting project because it involves a consortium of national labs, companies, utilities, and standards organizations doing research on blockchain for things like data integrity, management, and cyber resilience on the distribution level and distribution level assets. Again, I think this is interesting because it involves this holistic group of players who are more informed research on multiple sides, from labs to companies to standards organizations, and also hardware in the loop testing at national labs. So also Sage Security is an interesting example, which has received quite a bit of attention in the IoT world. And basically they're using blockchain for zero trust identity and data security on the distributed level for operational technology, IT, and cloud. And an interesting example of a partnership is a trial they did with ComEdge to demonstrate distributed security for decentralized access on the grid. And last but definitely not least, data procurement. Because as you all know, the AI market is huge, and AI needs really good quality data and a lot of data. to feed into machine learning algorithms, for example. So blockchain can be a very important platform and a way to share data as well as analytics in a secure way among multiple parties. I'm going to explain what I mean by that with some examples. So, for example, Science has developed a platform that uses blockchain smart contracts and AI to securely share data and even query data and analyze data from where it is. And smart contracts are then used to share this analysis with whatever members are in the consortium. This can be really, really useful in the power sector, for example, in predictive analytics and more informed replacement and purchasing decisions. And VIA became aware of this and started the Global Data Asset Collaborative, or GDAC, with founding members like Hawaii Electric and Vector. And basically the purpose of this collaborative is to pool and use utility asset data for analysis in a secure way. And more specifically, I believe they focus on transformers and predictive maintenance, replacement, and purchasing decisions for transformers. And in China, the Chinese startup OneChain was really recently selected for a feasibility study to use blockchain for national data management by the State Grid. And the State Grid basically is like the biggest utility in the world. So this is really a big deal, I believe, for blockchain. And this is interesting because State Grid aims to use a huge amount of data it has across departments and divisions across the country in analytics, but it also wants to maintain data privacy and consumer privacy. So it's looking to blockchain for multi-party data collection and sharing and computation in a secure way. So this is another really, really interesting example I think is worth looking into and following. So these are some near-term use cases I think are really interesting, but what could be next? Today, with the level of decentralization on the grid, it is growing, but utilities can still kind of cope. But when decentralized assets and connected devices increase, utilities will need to find new ways to coordinate these assets, which will become really, really complicated in the long term. Shown in this graph is how we expect small-scale PV and batteries to grow over the next 30 years. So it shows basically that their cumulative capacity will surpass 2,500 gigawatt in 2050, from about just 250 gigawatt today. So this just shows the scale of decentralization and added decentralized assets that is going to happen. So this means a huge opportunity for blockchain and smart contracts could indeed be supporting peer-to-peer trading or transactive energy models. The technology could lay the basis for record keeping, autonomous trading, transaction settlements, and granular orchestration of all these decentralized assets to really take advantage of these assets in grid balancing and kind of use smart contracts as well to compensate them for their flexibility services. So this really does make sense. We have more and more distributed energy assets, and this means we also need more distributed computing. However, while blockchain, again, can be disruptive for transactive energy and enable autonomous transactions among distributed assets like rooftop solar, batteries, connected devices, electric vehicles, charging stations, smart homes, the list goes on. And these distributed assets can be really valuable for grid operators to balance the grid and also to decarbonize the grid. However, whether this happens or not is really dependent on a multitude of factors outside the scope of blockchain, which are important to keep track of. So things like market decentralization, will our markets even susceptible to this kind of transactive energy trading? Regulations to support this, and also supporting technologies like 5G and IoT. If we're going to scale up blockchain to millions and millions of devices, it means we need really good networks and really strong sensors and very improved AI algorithms to support these transactive models. And also on the blockchain side, can blockchain now even be scaled up to all of these assets? And this is why I think a lot of companies are still working on the blockchain itself, which I think is very good in order to make it more scalable. So this means we think it would be important to first kind of implement a data collection infrastructure, so kind of a base layer of blockchain, and then fine-tune algorithms as opportunities arise and regulations allow and markets decentralize. So in this way, we think blockchain could be a long-term play for utilities. Thank you very much. And that's all from me. And here's my email if you would like to get in touch. Hi, everyone. Please let me know in the chat if you can't hear me or something. And thanks, James, for your question. And yeah, if you guys have questions or comments or anything, please write in the Q&A or in the chat. And thank you for joining. Yeah, so James' question is there any need for standards in blockchain for energy, particularly to accelerate the transactive energy use case? I think there are. For example, I guess I have two examples of this off the top of my head. I feel like we can write an entire research report about it. But for example, if we talk about prosumers actually participating on the power grid, like right now it's not like actually legal for them in a huge majority of countries to like actually take part and sell to the grid. For example, I'm in Japan, and if they're going to do that here, they would need to actually acquire like a retail license or like a license to sell, which doesn't make sense because like they're just one person, and retail licenses also involve a bunch of other fees and legal requirements. So transactive energy would involve like even small assets kind of selling to the grid. So I think that would need like new regulations and from everything from cybersecurity to how they are understood on markets. And then I guess the second is just like how utilities make money. Because right now, for example, in the US, in most parts of the US, I see some change in this, but in most parts of the US, utilities, I think, make money off regulated returns, which means like capital spending on things like power lines or transformers. So that doesn't really incentivize like software for transactive energy. But then again, it's changing. We have more and more performance-based regulation, which means that utilities are being rewarded based on performance rather than how much they spend on power grids, like building up power grids. So I think there's a lot to do for standards and regulation, but that could be like an entire research report. So it's a really interesting area. And Bruce says, I don't understand the point of P2P, power exchange through the grid. How is that beneficial compared to each customer exchanging power with the utility? Yeah, I mean, I agree with you. I think like there's been a lot of P2P projects, and I think one of the main maybe lacking thing in these projects is an understanding of what the customers actually want. Do they even care if they know exactly where their power is coming from or exactly who it's going to? For example, if I can sell my power to my neighbor. I mean, not in terms of physical power, but in terms of the money. So I think transactive energy is a bit different though, that kind of devices will interact with the grid, like there'll be participants on the grid, including prosumers and consumers even for DR purposes. So I personally think transactive energy might be a bit more interesting than like focusing only on peer-to-peer trading. Maybe in some areas, like I think in some areas like Germany or California, there's a lot more of this community feeling where people want to like focus on local community and ensure that kind of money stays within the local community and stuff like that. And in terms of energy communities, but I think we need a lot more, especially customer research on peer-to-peer, and to see if it's even worth it to develop regulation for it. So I'd love to hear your thoughts as well about that. And let me put my LinkedIn as well if anyone wants to connect. I'm always happy to. Wait, how do I do this? Okay. I guess in the chat, I just put my LinkedIn. If no one has more questions, I'd also love to know like why you guys are interested in blockchain in the energy sector as well. Because there's so many things to write about in the area. So, or like maybe what you guys think is an interesting use case. Yeah, exactly. I believe like Rex would go through other entities. It's just about kind of tracking where the energy comes from in a credible way. So, for example, I was at I think it was the India Smart Grid Forum, something like that. And one of the panelists was talking about how like companies in Thailand or somewhere, some other country in Asia, sorry, where SMEs were worried that they wouldn't be able to prove where their products are being, like where their products are being made and what power it's using to companies in Europe that they're selling to, because now Europe has this like new carbon border tax. So it's becoming more and more important, I think, to prove for companies where like what kind of energy sources they use, especially with this huge new like ESG investment trend. I mean, it's always been a trend, but I feel like it's growing now with a bunch of, especially with a lot of new net zero emission goals in countries. So I think both market decentralization, but also these like new decarbonization goals are impacting companies, especially and corporates, which are then kind of coming back with demands for green energy. And there's like a lot of growing public scrutiny for these things. So it means they really need to make sure that they don't end up in some scandal, you know? So I also think Rex makes sense, especially in the short term. But we also think it is kind of a bit of a shrinking market because especially in Europe and the US, corporates tend to prefer PPAs because of like additionality in Rex, because PPAs kind of add more flames to the market, add more power to the market rather than more than Rex. They actually add a lot of funding, like stimulate new builds of power plants. But in Asia, in places where PPAs are less established, like Japan or China, I think Rex, this can be a big opportunity as well. I think another thing as well, since we're on the topic, is maybe carbon, like just in general, carbon tracking of like forests or agriculture, which can be interesting too. Blockchain is kind of beside the point of this presentation, just a general thought. Oh, cool, James, you're on the IEEE. Let's definitely get in touch if you want. Yeah. James, how can I get in touch with you? Because I couldn't find you on LinkedIn. It'd be cool to have just a call to hear more about what you're doing on in the task force. And hear your reply to the regulation question about transactive energy. I think it's a big question. Cool. I think time is up, right? Yes. So thank you all for joining, and let's keep in touch. Thank you.